So in this video we're going to be looking at solving basic cosine equations that have the form cosine theta equals A. And we want to start off with developing the theory behind how we're going to do this. So we know that if we have cosine of theta 1, so this is going to be a single angle, so I'm going to subscript them with a 1. Cosine of theta 1 equals A, where A is some side ratio between -1 and 1. That to figure out what theta 1 is, we would take the cosine inverse of both sides. And what we learned about the cosine inverse function is that we had to constrain the domain of cosine in order to develop an inverse cosine function. So the inverse cosine function can only give us angles theta sub 1 that are on the interval from 0 to pi radians, or on the interval from 0 degrees to 180 degrees. It can only give us angles running from 0 to 180, 0 to pi, or in other words, angles in quadrant 1 or quadrant 2. So if I think about where theta 1 lives, theta 1 is going to be some angle on the unit circle in quadrant 1 or quadrant 2, because this is the 0 degree to 180 degree rotation. I get quadrant 1 or quadrant 2 angles. So let's suppose theta sub 1 is an angle here in quadrant 1. That means that we have an x-coordinate of A, because the cosine of theta is the x-coordinate on the unit circle, and there's going to be some y value here that we don't care about. So we input theta sub 1, and the output is the x-coordinate on the unit circle. The thing to notice is that to get another angle that outputs a side ratio of A, what we could do is reflect this point down into quadrant 4, and if we do that, so here's our angle theta sub 1. If we do that, we're going to get the ordered pair A. X will still be positive in quadrant 4. The y value will be the opposite, but the y coordinate has no bearing on the cosine function in this case. And this angle, because we have reflected over the x-axis, is actually going to be theta 1, but the opposite of it. So it's going to be the opposite of whatever theta sub 1 was. This will be opposite of theta sub 1. So we'll get theta sub 1, or the opposite of theta sub 1, generating a side ratio of A. So here's what we want to do to take advantage of this even symmetry, actually, to generate all possible solutions, every angle that generates a side ratio of A. So here's the way to do it. You say, hey, I want to know cosine of what angles generate side ratios A. And then you're going to take the cosine inverse of both sides and get, hey, theta is equal to plus or minus the cosine inverse of A. Right? We get an angle, but that angle, the opposite of that angle, also generates a side ratio A. So we say, hey, there's two angles, plus or minus, by the even symmetry that's going on here. And then we want to recognize this only gives us two angles, but every coterminal angle also generates an output of A. So if I add theta 1 plus 360 degrees, or theta sub 1 plus 2 pi radians, I'll rotate back around and get this side ratio of A again. So we want to recognize that not only do these two angles give us a side ratio of A, but every coterminal angle does. So if I add 2 pi k, where k is some integer, I also get side ratios of A. Or if I'm working in degree world, I add 360 degrees times k, saying that every rotation of 360 degrees, so I start here, every rotation of 360 degrees brings me back to an angle that generates this side ratio. So this generates all possible solutions for the cosine function. So here's an example in practice where we have a side ratio that actually corresponds to a special angle on the unit circle. So it says find all solutions for the equation cosine theta equals 1/2, and all solutions on the interval from 0 to 2 pi. So the fact that we're being asked for solutions on the interval from 0 to 2 pi indicates we should be working in radians instead of degrees. So we're going to start with our equation. We're going to say, hey, cosine of theta equals 1/2. To dig the theta out of here, we take the cosine inverse of both sides. So theta equals the cosine inverse of 1/2. If you plug this into a calculator, this is only going to give you an angle between 0 and pi radians. It's going to give you an angle, the principal solution. It's going to give you an angle between 0 and pi radians. So here's the cosine function graphed. Here's the line y equal 1/2 graphed. And what we see is that we're going to get this guy right here. Theta sub 1 is going to be the principal solution. So when we plug in theta sub 1 into the cosine function, the output is the side ratio 1/2. So if we just did this, all we would get is this angle generating this specific intersection right here. But we recognize that the opposite of theta sub 1, so the cosine function has even symmetry. When we reflect this point over the y-axis, boom, we have another point that has an output of 1/2, but instead of theta sub 1, this is going to be right here the opposite of theta sub 1. So we get the opposite of theta sub 1 also generates a side ratio of 1/2. So to pick up two solutions, I just put plus or minus on the cosine inverse function. And then I want to recognize that every solution to the right of the crest, is going to correspond to a coterminal angle with theta sub 1. And every solution that is to the left of the crest, so to the left of the crest, is going to correspond to an angle that is coterminal with the opposite of theta sub 1. So to pick up all of the coterminal angles, I'm going to add plus, rotate 2 pi radians or once around a circle, do it any integer multiple, so we let k be an integer. We know that it's plus 2 pi k because we're working in radians from here. And then we need to look at this and say, hey, 1/2 is a special angle. So I actually know the special angle that generates that side ratio. So if I'm looking at the unit circle, if I go to 60 degrees or pi over 3 radians, that's going to correspond to the ordered pair 1/2 root 3 over 2. And the cosine function, the cosine is the x-coordinate. So what angle generates an x-coordinate of 1/2? Well, 60 degrees or pi over 3 radians. So because I'm working in radians, I'm going to replace cosine inverse of 1/2 with pi over 3 radians, put my plus or minus in front of it, and go plus 2 pi k. So this is all solutions that exist, all solutions. So they're specifically asking for the solutions on the, we did find all solutions, but they're also specifically asking for the solutions on the interval from 0 to 2 pi. So if we clean this up just a hair for a minute, to get the solutions on the interval from 0 to 2 pi, I want to recognize that the interval from 0 to pi is a subset of that interval. So the positive cosine inverse is going to be one of those solutions. The positive cosine inverse always gives us an angle between 0 and pi. So it definitely gives us an angle between 0 and 2 pi. So for the positive guy, I'm going to let k equal 0 and just say one solution looks like theta equals plus pi over 3 plus 2 pi times 0, which is just, hey, pi over 3 is a solution on the interval from 0 to 2 pi. And for the part of the equation that's minus, I recognize that minus, the minus theta 1 is sitting over here. So I'm going to need to add 2 pi radians to it to get to the next point. This is to the left of the trough. or the crest. So I'm going to go to the left of the crest. I'm going to add 2 pi to get to this guy. So I'm going to let k equal 1, and I'm going to get another solution. It's going to be theta equals negative pi over 3, grabbing this solution here, and then adding plus 2 pi to it. And then we can find a common denominator. So it's going to be negative pi over 3 plus, it's going to be 6 pi over 3 is still 2 pi, and that's going to give us 5 pi over 3 radians. So the two solutions are, to get the solutions on this interval are theta equal pi over 3 and 5 pi over 3 are both elements of the interval from 0 to 2 pi. We could have got this less mechanically just by thinking about the unit circle, of course. There would have been, I mean, there's more than one approach to doing things. We could have said, hey, here is an angle pi over 3 that's generating my 1/2. I know I need to get down here where I get 1/2 comma negative root 3 over 2, 1/2 positive root 3 over 2. What is this angle? Well, this angle is going to be 2 pi minus the reference angle, which is pi over 3. So we could have gotten it that way as well. But that just turns out to be, if you look at this, 2 pi minus pi over 3. There it is. So one more example. Here's an example where the side ratio isn't associated with a special angle, but the process is the same. Hey, find all solutions for this equation on the interval from 0 to 360 degrees. So I always like to just find all solutions first. So we know we're working in degrees. So we get cosine of theta equaling negative 1/3. Take the cosine inverse of both sides. We know we're going to get plus or minus that angle that results. Plus or minus that angle. And then to get all coterminal angles, it's going to be plus, but we're working in degrees, so it's going to be plus 360 degrees times k. And this gives us all solutions in exact form. And if we want just the solutions on the interval from 0 to 360, we recognize that the positive angle on the interval from 0 to 2 pi, the positive angle is going to give us this, the angle on the interval from 0 to pi. This is going to be the first answer. And then the negative angle is the angle over here. This is the opposite of theta sub 1, and we need to add 2 pi radians to that to get to the next place. That is a solution, so we got to jump. This is to the right of the trough, so this one's to the right of the trough. We add plus 360 degrees to get over there. So the two solutions are going to be theta equals, it's going to be the positive cosine inverse of negative 1/3, and then from the negative we let k equal 1, and we get the opposite of cosine inverse of negative 1/3 plus 360 degrees times positive 1, sorry, because we're moving it forward, times 1. And this is going to give us the other answer. These would be exact. And if you needed to approximate them, you could just step into your calculator and get the approximation. You just need to check and make sure you're in degree mode, not radian mode. Again, just in case that was too snippy, so stop the video now if you understood that. If you didn't, if I erase this, plus the cosine inverse always gives you an angle between 0 and 180 degrees, or 0 and pi radians. It always gives you an angle between 0 and pi. So when you're looking at the intersection of the cosine function with negative 1/3, that intersection that is on the interval from 0 to pi is going to be the plus cosine inverse if we let k equal 0. So if we let k equal 0, we get one solution at theta equals plus the cosine inverse of negative 1/3 plus 360 degrees times 0. So we just lose this part. We recognize that the principal solution is on the interval we're interested in. The other solution is going to be from taking the opposite of this. Here's theta sub 1. Here's the opposite of theta sub 1. And we're going to need to add something to it to get from this point over to this point here, which is a period away, but on the interval from 0 to 2 pi. So for the other one, we let k equal 1, which gives us theta equaling negative cosine inverse of negative 1/3 plus 360 degrees times 1, which is just plus 360 degrees. These gives you the exact two angles on the interval from 0 to 360 that work. It gives you this and this. So this angle right here is really theta, the opposite of theta sub 1 plus 360 degrees is the angle associated with that point right there. If we wanted to approximate it, we put it into a calculator.